Sorry, guys.
Well, Austin was asked, and I said yeah, but I didn't really think about it. So
Wow, thanks for the reminder. Yeah,
usually,
I totally spaced that one. Sorry.
I usually pause and like, all right, here we go.
Yeah, we're recording now.
Well, just for the record, we already did 1, 2, and 3.
Yep. Um, let's see. Number 4. Austin, do you have that one, or do you want me to read it?
Yeah. What does the phrase discrete random variable mean? Discrete random variable is something that varies following a specific pattern or distribution over the long run. They're discrete if they can be listed.
Okay. So I know that that's kind of what the definition is. I don't really understand what it means to be listed. That just means you can specify those?
What I think it is that it's not like a like you can actually predict the amount of
Yeah.
the randomness.
Okay.
It actually has like a quantitative value to it. So otherwise, it's like let's say to be struck by lightning, like there really is no statistic because there's so many variables in it that you can't just say, well, my chance of getting struck by lightning today is 10,000 billion to 1.
Right. Okay.
So it's like a listable variable or outcome or probability. That's what I kind of took from the reading.
Yeah, that makes sense. Okay. All right. So section 2. So it looks like we have a 4-sided die. A 4-sided die has 4 possible outcomes for each roll, 1, 2, 3, or 4. Calculate the mean of this discrete random variable. So.
Sure. Well, Austin and I met last night, and we kind of went over that.
Okay.
I'll show you. We made this little calculator. Basically, you just punch in the numbers, and here's your stuff.
Cool. Hey, Jared.
Hey.
How you doing tonight?
All right. Sorry I was late. Just got back from Scouts. So.
Oh, no worries. So we're just going over the preparation assignment. We did questions 1 through 4, and then we're starting on part 2.
Okay.
So Jared, also we have a new guy on our team. This is Austin.
Hey.
He's in a different class, but all the people in his group dropped the class, so.
Oh.
He's kind of lone wolfing it with us.
All right.
So yeah, when we're done, you'll just have to copy the URL and send it to Austin, so that way he can paste it in his class. If that's all right.
Oh yeah.
So as you can see, I already did the math. So it's asking for the mean of this discrete random variable, and the mean is the sum of the probabilities, which is this section right here. Yeah, that's 2.5.
Okay.
So in case you want to know how, or you don't know how you did that, so there's 4 events, and then you just take the probability of that event, which is 1/4 for the time. You'll get a 1, a 2, a 3, and a 4, and then you times that probability by the event itself. So that's how you get these numbers, and then you just add them up and you get the sum of the mean. And then number 6 is the standard deviation. So going a step further, you just the sum of the probabilities. Let's see. How do I do this? Oh, it's the event value minus the 5. Oh, minus the sum squared times times the probability. All right, so that's what I did. So in one part of the equation, you just take the event itself, subtract it, subtract the sum from the event, so 1 minus 2.5, square that, and then you times all that by the probability. So I did that for each of these, and then I believe when you add those up, you get the variance, and you square root that, and you get the standard deviation.
Cool.
So standard deviation is 1.118.
Okay. Thanks, guys.
Yeah.
Anybody have any questions about that?
It's all good. Do you guys feel confident in, like, I mean, I know you kind of cheated with the calculator, but do you guys feel confident that you already know how to do that anyways? Or?
Yeah, I think so. There's a video there that walks you through the process of setting that up. So that's if you watch that and set it up, you should be able to
We're all good?
follow through. How about you guys, Zach, Jared?
Yeah, it makes sense. I'm pretty good with it.
Okay.
Yeah, just kind of plug and chug, it seems.
Yeah, good.
Okay. Do you want to jump down to the quiz?
Mm-hmm.
Sure.
All right. All right. We don't have to open any files beforehand like we did last week. So that's good. Let's hope it doesn't all melt down.
Ready to go.
Okay. I'll read number 3. Give all your probability answers as decimals. Do not give probability answers as percents. Okay. Human blood can be classified into one of, is that supposed to be 4? One of our basic types, O, A, B, and AB. The proportion of people in the population of the United States with each of these blood types is summarized in the following table. Use this data to answer the following questions. The blood types and the proportions given in the table above define a probability distribution.
I don't get it. What's proportion?
So those all should add up to 1. All those numbers should add up to 1.
Yeah.
So it's like a percent of each of those.
Yeah.
So,
Each of them considered a probability.
yeah. So that's the probabilities of each one?
It's saying, is it?
Yeah, I think so.
Mm-hmm.
But those don't add up to 1, do they?
I think they do. 40,
Oh, wait.
85, 90, 96, and then 4.
Yeah. Sorry. Little remedial math issue on my part.
The reading, it talked about how genetics are one of those things that is a random probability, that because of the way that genes split up and everything, that it is random, and this is the population of the United States. It's pretty big sample size, and so it looks like that's probably the probability as well. I think that's just the percent. I don't know if it's a probability distribution.
Probability distribution.
Because I feel like oh, maybe that's right.
Oh, I see. In the question it says the proportion of people in the population of the U.S. Have each of these, so that is a percentage.
Yeah.
So they're saying 45% have O and 40 have A, so and they all add up to 1, like Austin said. So that answer would be true.
But
Yeah.
just because it's a percentage doesn't mean that that's a predictable, like you can probability of A and B or O or B type 1.
Well, let's see the blood types and the proportion are given in the table above. Define the probability distribution.
Is that a true statement?
Sounds true.
Yeah.
I
Yep.
think it is true. That's fine.
Yeah, I think it's true also.
Yeah, that's what I'm thinking.
Okay. So number 4. Somebody want to read number 4?
Yeah, I got it.
Okay.
What is the probability that a randomly selected person in the United States has type O blood? Round to 2 decimal places. So I was looking at it. The obvious answer would be 0.45, but it seems like there might be an equation involved if they want us to round. So,
Yeah, I think it's just 0.45.
yeah?
I think it's just that easy.
Okay.
Yeah.
Well, I guess a random person, yeah. Yeah. That makes sense.
What is the probability that a randomly selected person will not have this? What type? So it would be 1 minus, yeah. So that'd be
0.55.
point.
So that would be 0.55, correct?
Cool.
Next one.
Okay.
Okay. Caroline Willis and her colleagues conduct a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrated that the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. Answer the following question. If the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient? Round the answer to 3 decimal places.
That'll be 1 and 7, right?
Yeah.
Yeah, 7 bowls.
So is that 0.143?
Yeah.
Yeah.
1, 2, 3.
Good.
Okay.
I'll read the next one.
Thanks.
In a combined total, in a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that a dog would do this well by random chance alone. Which of the following statements is most appropriate? This provides strong evidence that dogs can detect bladder cancer, or there is little evidence that dogs can detect bladder cancer.
I think the first one, right?
Yeah. Mine are actually reversed, but so there's strong evidence that dogs can.
Strong evidence, yeah.
I guess it's strong enough.
Maybe that was
Out of 54.
Yeah. So like half the time.
Yeah, that's close to half.
They have
It's
a,
more than random, though.
because they had a 1 in 7 chance, which means they're doing way more than they should.
Yeah.
Yeah, that's true.
45% is way bigger than 14%.
At the same time, it's like, I don't know. I guess the answer should be strong evidence, right?
Yeah.
Yeah.
Hmm.
This is really hard to determine if it's significant. Because little evidence still means that it is beneficial. Like it's saying it's speech detected, but
Right.
so.
Hmm.
Well-
50% is still not good. Better than 14 though.
Yeah, but it's significantly higher than what would be expected.
Yeah. So like 3 or 4 times, 3.5
Yeah.
times stronger. So
Right.
I'm okay with going stuff.
Okay. Is it my turn again? Or has everybody gone?
Yeah, I think so.
Yeah.
All right. So back. All right. M&Ms are small chocolate candies. Really? The M&Ms website previously indicated in the United States the distribution of the colors in a bag of plain M&Ms is given in the following table. If you reach into a bag of plain M&Ms, what's the probability of drawing out a red-colored candy? So red is your green scratched out?
Yeah, the green scratched out.
Okay.
Um,
Oh, so we need to. Okay.
You find the green.
Well, you want to read off the probability real quick?
Wait a minute. What is the probability?
Yeah. So brown is 0.13. Yellow is 0.14. Red is 0.13. Blue is 0.24. And orange is 0.2.
Red should still be 0.13, right?
Yeah, red would have to be still 1.13.
Yeah.
But then we subtract all those numbers from 100 to get green, right?
Yeah.
So it
Yeah.
comes up to 0.84.
yeah, so 0.16 for green.
Yep.
So what was that? 0.16?
For green, the green one.
All right, cool.
Yeah.
And then, yeah, the probability that it's not green is just 0.84.
Oh, 0.84. Yeah.
Probably one of the M&Ms.
The ACT scores of students admitted to a medium-sized public university in the Western United States were taken from capex.com. The following summary statistics were calculated. Mean 24.3, standard deviation 4.3, variance, all that. Okay. Use information from the public university to answer the following questions. Half of the observations are less than or equal to what number?
24.
Let's see. Half of the observations are less than or equal to what number?
The 24 or 24.3?
So half of them, 1, 2, 3.
See, isn't the median the 50th percentile?
Yeah, the very middle, so it has to be less than or equal to. Yeah.
Yeah, so it'll be 24, right?
Yeah.
That's right.
But remember, we got that one wrong last week. I think we're right this time.
Yeah, well, they were looking at the box chart, and we forgot it wasn't the mean, it was the median.
Right.
Median.
Right.
The line like in the middle of the box. They specified that it was the median. Based on the information on the table above, the top 25% of the students scored above what number?
Is it 36?
No, I think it's
25%
Would be the third quarter.
would be the third quartile, so 27, right?
yeah.
Oh, okay.
That's tricky. That's kind
Yeah.
of dumb. Why would they say that? Why don't they just say the 75th percentile? Yeah. Seems like every test there's always that one question that's like a little tricky.
Right.
Okay, which of the following statements is not one of the 3 rules of probability? answers are the sum of the probability in any probability is 1. The probability is a number between 0 and 1. The probability that an outcome will occur is 1 minus the probability that it will occur. If the probability is high and the probability is positive, the probability is low and the probability is negative. That's the one.
That's the wrong one. Yeah.
Cool.
All right.
Ready?
Should we submit?
Yeah, moment of truth.
There we go.
You go first, Jared.
Yeah, 100%. That's what I like.
Nice.
I think that's the first one.
Yeah, we were due.
Nice. Cool.
All right.
Awesome.
You guys have any questions? Anything you want to go over before we head out?
I'm good.
I'm good.
Yeah,
If you could send it to Austin, that would be great.
I will. Let me just confirm your email address. It's austintsimmons@gmail.com.
Yes, sir.
All right, I'll send you the link as soon as we're done here.
Awesome. Thank
All
you.
right. Thanks, you guys. Tomorrow, or not tomorrow, Thursday at 9.
Thursday at 9.
Okay.
See you then.
Yeah.
All right. See ya.
Bye.